Hey everyone, I am Zach, co-founder of Hot Data, and today I'm here to talk a little bit about our adventures of building a Rust native library to connect to DuckLake, a new open table format, and open sourcing that. So first, just to for anyone unfamiliar, Apache DataFusion is a technology we are using. It is a library written in Rust. And out of the box is a fully working database, but kind of the beauty of it is every aspect of it is fully customizable. So for folks trying to build new databases, rather than starting with all of the primitives, you can start with DataFusion and get this incredible query engine out of the box and then customize it to your use case. It's very fast, built on other great open source technology like Arrow. And yeah, it is a really wonderful toolkit. And then DuckLake, the other thing we were talking about here, is a newish open table format from the DuckDB folks that came out last year. And effectively, for anyone that hasn't heard of DuckLake, this is a lakehouse table format, which basically means you have a bunch of data in files, and you need to know some what those files represent. And so that's stored in metadata. This is very similar to Iceberg. And with Iceberg, you similarly have the files, and then you have the metadata. But for Iceberg or Delta, that metadata is managed in various metadata files. So for Iceberg, at query time, you have to kind of go traverse these various different file formats and look up all the relevant data and put that together. What the DuckDB folks did was take a lot of those really great concepts and bring this simple elegance to it, which is store the metadata in a basic relational database. And so at query time, when you want to know about what the relevant data is, you can just perform these queries and get that metadata and then go execute against the files. So my co-founders and myself previously all worked together at a company called Mode Analytics, which was then acquired by ThoughtSpot. And there we operated the data platform. Just to give a sense of scale, when we were there, we were ingesting like 250 terabytes of customer data a month and like 50-some million queries. And we would take that data and then we would perform analytical queries on their behalf to help power the BI tool, the visualizations. And we had, over the years, built kind of a homegrown table format there. We had all this data stored in S3, the metadata stored in Postgres. And it worked really well for our use case. But as time went on, things got challenging as custom integrations do. So every time we wanted to add a new access point to this data, it was another custom integration. And then over time, as we tried to bring lakehouse-like features that customers were asking for, it was very challenging. We seriously considered migrating over to Iceberg in like 2022-ish, and ultimately found it just being too operationally complex, and we had some serious concerns with the latencies of queries with assembling that metadata at runtime. So when we started this company, Hot Data, we wanted to build on some of the knowledge we had from Mode, and those analytical queries I was referring to. One of the things that worked really well at Mode was using DuckDB as the query engine. And so our early prototypes used DuckDB, and being such fans of DuckDB and having so much success with it, we had been following DuckLake from afar. And so we started experimenting with DuckLake and using DuckDB. As the prototype evolved, we kind of ran into areas where we wanted to customize it more and eventually stumbled upon DataFusion and kind of quickly fell in love with Rust and DataFusion and were able to make some really great progress building on top of that. We were still really interested in DuckLake, and at the time there was not a native integration. And so we started to get interested in how could we utilize DuckLake with DataFusion. One thing that we surprisingly run into a lot is folks don't realize that DuckLake is just a spec. There's no dependency on DuckDB itself. It is the reference implementation, and it's a great implementation, but you can completely use DuckLake without DuckDB at all. So in this case, we had such great experience with the DuckDB team and the folks there, and thought the design was great and wanted to utilize it, but wanted it to do so in a native way. So that's what we did. We set off on building this integration, and although it was a custom, like we own the implementation, it was kind of an interesting experience for us because we're building against this new spec that we don't own. So building against this interface. And given how new it is, some of the things we ran into was just like, how do we go about like what features are important? And it seems kind of simple at first, but as we dove into it, like there's kind of the spider web of different features and features that are hidden underneath the covers that you don't think about that you need to support to be able to support something else. And then just more generally, like what even matters? Like what is the most important thing and in what order? We needed to build something that was useful for ourselves, but we were also hoping to build something, again, for the community and other people would find interesting. And so ultimately, basically, the way we approached it was starting with read support, very common for these sort of integrations, and then adding over time like additional like DuckLake functions, and eventually getting to a point where we would be able to do write support, and ultimately where we would like to be, we're not quite there yet, is 100% feature parity with the DuckDB implementation. And so that's what we've done over the last couple of months. We've added read support. We support all the different metadata backends that the DuckDB extension supports, different object storage, lots of the different little like row level deletions, and most of the non administrative functionality, so nothing like compaction or stuff like that. And then just as of a couple weeks ago, we added the first write support. So we kind of had this building up to it with lots of the read and performance and making sure that was working really well. We started with inserts, hoping to follow that up with updates and deletes. This was exciting to get that there. As I said, more changes, more features coming along. These are a couple of them. Time travel queries are something we're really interested in. And ultimately, we really do want to be feature compliant or have feature parity with DuckDB. But kind of the next chapter, we're like looking more to get feedback from community and help have that inform the prioritization of what we build. So kind of like reflecting on this experience, there's a couple lessons we've learned and like observations we've had for this use case of building against this interface, particularly a new, rapidly evolving one. And so some of the challenges we ran into was really deeply understanding the spec. The DuckDB folks have done a really good job of documenting a lot of it, but much more, or at least at the time we were starting, much more user-focused rather than implementer-focused. And so understanding like what actually is the spec required a lot of like diving into their implementation code. Even things like, here are the metadata queries you need to run, ended up would differ from the documentation to what was actually had to be used in the code. Building on top of that is like, how do we know our implementation is correct? And kind of the common way to do this is just use an implementation that already works to kind of test against. And that worked, that's basically what we did. But the problem with this is every new implementation that comes along kind of has to build their own little like wrapper and harness around that to make it work. And so something we think would be really great is like more like centralizing this information. We've actually, the DuckDB Labs folks, Pedro, Guillermo, have been really receptive and great collaborators talking to us about this, of how to incorporate some of this feedback. And there's some great ideas coming out of like how we could do this and put this into kind of a repository to make it easier for future implementers, as well as for ourselves and them. And then this last one's kind of a like pipe dream, but as we talked about, coming up with the feature prioritization is hard, and like you don't necessarily know what is important. And so as DuckDB learns more and understands what users are using, like being able to add that, like, you know, quantify some of these features of like, this is really, most people are using this feature, or most people are using these features, could be a really strong signal for future implementers as they're deciding what to implement. And then kind of in closing, why this matters to us. Like, sure, we could have used DuckDB directly, but we think like the more options there are in open source, the better we are. And this is going to help make this a stronger spec by having more of us working on it and not just have it be a specific DuckDB thing. And yeah, we want to like be part of that community and help make it a stronger standard. So that, we'd love for any of you to give it a try. Any sort of contribution would be great, whether it's feature requests, let us know how you might be able to use this. Tell us what we got wrong, bug reports, and certainly any PRs we would take as well.